And there's plenty of parking today too.
Yeah.
I think maybe it's, well, I got here later or so, I don't know. I got a really good spot too. Okay, so what I'm gonna do is I'm gonna go over Unit 3 reactions and hit upon Unit 2 reactions as well. Now, I've just, again, I was telling you, I was just talking to Dr. Huang, he's the department chair, and it's his class, and we were talking about reactions. And he says, oh, his students, he teaches the advanced organic. His students don't like reactions either. And I said, I've been doing this for 18 years and 18 years worth of classes, and no one likes reactions. But it's kind of a necessary evil. But what's good about it, though, it shows you what real organic chemists do. They do reactions. That's all they do. When I was in grad school, same thing. Reactions, reactions, and more reactions. So it's good you get a feel for that. Okay, so let's talk about Unit 3 stuff here. Okay, so Unit 3 reactions are acids, esters, and lipids. Not so much lipids, but for sure acids and esters. Okay. I also was telling him about our tie dyeing. So if any of you are interested in tie dyeing, do it before the 8th so that he can see all my students with tie dyes. Okay, I'll start with let's take what happens to an acid in water. Okay, this is a 1, 2, 3, 4. So this is a butanoic acid. So what happens when you throw any acid in water, whether it's a strong acid like hydrochloric or nitric, or a weak acid like butanoic acid, it's going to disassociate. That means now in some books, they'll say it isn't H plus, it's really H3O plus. That's called the hydronium ion. All that means is the H plus hooked up with a water molecule. Okay, so that's pretty standard. We have to name everything. So this is going to be butanoate. So this always happens in water. Now, there's two kinds of acids, as I was mentioning. There's strong acid and weak acid. Strong acids, everything, all the H's come off that are acidic. Weak acids, part of them come off. That's what makes them a weak acid. So butanoic acid is an example of a weak acid. It's also very, very stinky. This is what gives cow patties their lovely aroma, butanoic acid. Back when we did the ester lab up in Tacoma, all the waste stuff, it was very sweet smelling, but occasionally we got some of the original butanoic acid in the waste. Smelled up and down the hallway. One person was walking down by my lab and she thought it was the restroom. It was so bad. Of course, I'm recording all this for posterity's sake here. All right. So by definition, one of the H's comes off. Bless you. I should say one or more. Sometimes there'll be two or three, like citric acid has three that comes off. Okay, so if there's an H present, there's a possibility it's an acid, but it's got to come off to be an acid. If it doesn't come off, it's not an acid. Okay, for example, if we put butanol in water, nothing happens because there's no H to come off. That's key. No exceptions. To be an acid, H has to dissociate from the original. Okay. And this is any now pH 7 is neutral water. Did you go over pH a little bit in 305? Is that a yes? Okay, so you know 7 is neutral then, right? Okay. All right, well, what if it's not neutral? What if it's acidic? Less than 7, okay? Still in water, but acidic water. Okay, what happens is no reaction. What if it's greater than 7? What happens then is we have so if we have sodium hydroxide making it pH greater than 7, then you're going to end up with the salt. So that's going to be sodium no, butanoate. Butanoate. Okay. So whenever you see that, it's a salt. Okay, so you need to know this. 3 different pHs, what happens to acid? Now we get to the next unit, unit 4, it's going to be the same thing. We're going to have the results at 3 different pHs, which is the exact opposite of what acids do. Those are called nitrogen bases. They act differently in different pHs, but exactly the opposite. So there's going to be a test question, test 4, contrast the two. Okay, does this make sense? Yeah. Okay. So you answered his question, okay? Okay. All right. Okay, well, how do we make an ester? So let's make an ester. Okay, we have an OCO. One's a double bonded O. Boom. Means it's an ester. Means we've got a primary and a secondary. backbone. And the side that's got the double bonded O is the acid side. The one with a single bonded O is the alcohol side. So to put those together, we need to start with one of three things. A 1, 2, 3, 4, 4-carbon acid. Plus a 2-carbon a 2-carbon alcohol for the secondary backbone. There are three ways to make an ester. That to me is the most fundamental way. It's also the poorest way. The other way to make an ester is instead of the acid, we're going to use the acid chloride instead. Okay, so this is the poorest yield. Best yield. And then in the middle of the road, which we used in our aspirin lab using the anhydride. Now, everyone gets confused about anhydrides. I just tell everyone, think of it as two esters stuck together. Use the anhydride. Okay, we're going to call that butyl anhydride. When you use the anhydride, you make the ester plus the other half of the anhydride becomes an acid. And when we make aspirin, the same thing happens. We end up creating acetic acid. Old aspirin frequently will smell like vinegar. The reason for that is the anhydride part of the synthesis is coming apart and giving you acetic acid. Okay. So, using the anhydride is the middle of the road. It isn't the best, it isn't the least, but it's usually people use the anhydride because anhydride lasts longer on the shelf. So it's much more shelf stable than the acid chloride. Acid chlorides work really well, but one, they're expensive because they don't last very long when you buy them. Because they react with moisture in the air. So you have to keep them in a sealed environment and they're a real pain to use, but it gives you a much better yield. So it's always, everything's a trade-off. Using the acid, you get a very poor reaction. So you get the least yield. It's also the most shelf stable. So again, pros and cons here. Okay, that will be on the test, that question. Okay, yeah.
How do you name that?
Oh. Okay, naming esters in two parts. So the first part is the alcohol part, which in this case is ethyl. Then you name the acid part, which is a butanoate, just like a salt. And there's no branching or anything like that. If they're branching, you'd have to include that over here. Okay, so Tuesday, you're gonna have a lot of naming, a lot of structures, and a little bit of intermolecular forces. And on Thursday is when you can do this kind of stuff. Okay, so 3 ways to make esters. When we get to the next unit, there are 3 ways to make amides as well. Very similar, only it's with nitrogen rather than oxygen. Okay, so one of the challenges in organic chemistry is multi-step synthesis. So this is a one-stepper, the simplest kind of reaction. Now, multi-step reaction has 2 or more single steps put together. Now, it's real important to look at your flow chart. Okay, now when you're doing multi-step synthesis, it's really handy to have the flow chart next to you. And of course, I'll give you this for the test on both days, along with your different 3x5 card. Sorry. So to use this flow chart when you're doing synthesis is you find 2 spots on it. One is the reactant side and the other is the product side. So let's do a multi-step problem here. And let me show you what I'm talking about. So let's want to make that ester from start from that. Okay, so we've got an ester. Here. That's one spot. Now we have to identify a second spot. Okay. That. How do we go from a bonded two carbon alkene to an ester? Okay, so we've got some arrows to go through here. All right. Well, we need to have an acid. Okay, so how do we make an acid from that? Well, let's see here now. If you remember from Unit 1 chemistry, we have here is this is the acid. Oops. And how did we make that? Well, we oxidized aldehyde. All right. Okay, if you oxidize an aldehyde, we're not starting with an aldehyde, we're starting with an alkene. So how do you get an aldehyde? Let's see, let me.
Alcohol. Oxidize the primary alcohol.
Exactly. To get a aldehyde, we oxidize a primary alcohol. And how do we get a primary alcohol? From an alkene. So identify your product and then just back up. Okay, so we start with the alkene. Add to the alkene water. And some acid, either H plus or H2SO4. That gives us alcohol. Now, notice up here, we have a two carbon alcohol. So what do we have down here? We have a two carbon alcohol. So we're partially there. Okay, so that's the alcohol part. We need to get the acid part though. Okay, so here's the acid, and we're going to oxidize an aldehyde. Well, if we start with a primary alcohol that we get from the alkene, we're going to oops, Now we're going to oxidize that primary alcohol. That goes first to the aldehyde. Then to the acid. So we've got the alcohol and the acid parts. So now we're going to take these two, and that'll get our ester. That's an example of a multi-step synthesis. It's not a one-stepper. So you're gonna have one of those Thursday.
So the test got moved from next Tuesday to next Thursday?
No, you weren't here when I was talking about it. Next week, we're gonna have, tests gonna be in two parts. Tuesday and Thursday. And I know you have to. Right. Tuesday is just gonna be naming structures, intermolecular forces, and all the reactions are gonna be in Thursday. Because everyone has most trouble with reactions. That'll give you some extra time to focus on that. And I'm gonna combine the scores together, though. There's gonna be one test. That makes sense?
Yep.
Remember before I had the harder version, the easy version? Everyone goes, well, why would anyone want to take the hard version? I was kind of like, that's true. So I changed it to this. Let's see how it goes. Okay. Are there any questions about this multi-step synthesis? I'm telling you right now, this is the hardest part of doing reactions is when it's in more than one step. Yeah. Yeah, the ester is made up of two parts, alcohol and acid. Now, first we make the alcohol part, which is the top one, then we make the acid part, the bottom one. And we combine those two together, to make the ester. Huh? Yeah, you're gonna have one of these on the test Thursday. Yeah. Yeah. To do each individual. Yeah, basically that. Now, what I'm not gonna do is I mean, this happened to be a very similar path for both of them, but frequently it's not. Sometimes you have a different path for each part. This happens to be a similar path for both. Because both stem from the primary alcohol you make from the alkene. Okay, I'm also gonna have some questions like that molecule. Let me redraw it so it's easier to see. It's kind of hard to see. Okay, so I give you Oh, not quite the same. So I give you a molecule, and the question is it saponifiable? What do you look for? Just like when we're doing a reducing sugar, remember you had to look for what? The what? Hemiacetal. The hemiacetal was present, it was reducing sugar. Okay, with esters, excuse me, with any molecule with an ester in it, it's saponifiable. So if I have a pH greater than 7, that'll take that ester apart. Um, that was what I had originally. Okay, so that'll take the ester part apart. Now the other parts are going to stay by themselves because they're stable in a basic environment. So the ester is not. We're going to take the ester apart, and it's going to give you two things. It's going to give you an alcohol and the primary backbone, which is going to be the acid. But it's going to be the acid salt. If it was in a sodium hydroxide solution making the pH greater than 7, what's going to happen is we're going to take this that's the original backbone. Make the salt from it. Plus the alcohol. So that's a 2-carbon alcohol. Okay. So what saponifiable means is we take apart an ester in a basic environment. I don't know if you remember on the practice test that I had an extra credit problem on there. I took lecithin and I said, is this saponifiable? Now, lecithin's a really complicated molecule. Let me draw it for you. But the question is the same though. Is there an ester present? Yes or no? If it is, doesn't matter how complicated it is. One class up in Washington, I gave a take-home problem. I gave them vitamin B12. I said, is this saponifiable? And vitamin B12 is this humongous looking thing. It's got all kinds of parts on it. You just go through and find an ester. There's an ester there, yeah, you can saponify it. So it doesn't matter the complexity. Question is yes or no, ester present. If there is, saponify it, as long as it's a basic environment. Now, if there's an ester present in a, in fact, let's do it in an acidic environment. So in an acidic environment, you're just going to take it apart. Esters are susceptible in an acidic environment. So what we're going to do is So you have the acid, not the acid salt. You can guess what the name of this guy is. Well, it's benzoic acid, the base. And we've got two branches off the benzoic acid, hydroxyl group and a nitro group. Okay, H comes before N, so it is so 2-hydroxy, 3-nitro benzoic acid. This could be also nitric. One's going. Base is benzoic acid. Okay, what other kinds of reactions are we talking about here? The main challenge is going to be multi-step synthesis, the reactions. Also, the structures are going to be challenging as well. It's another reason why I want to split it up. So focus on some of those, DHA and EPA structures and stuff. Okay, so let's go back to Unit 2 reactions. Are there any questions about what we've done so far? Any of these guys? Okay, the main thing is once you identify it's an ester, find the alcohol part, find the acidic part, and that's what you're going to do to assemble them together to get the ester. Okay, so let's look at now some Unit 2 reactions.
How many reactions we're gonna do on the test?
I don't know. I haven't made it up yet.
So we're gonna do unit 2 and unit 3.
Yeah.
So it's essentially like a big test.
Oh, already studied the reaction freedom, so. I know, a while ago. It'll come back. It's a matter of reference. It's just like, remember, there's no final in this class. This is like, every test is like a final. Because it has to use previous stuff. Like on that 2-part multi-step synthesis, then we use reactions from Unit 1, Unit 2, and Unit 3. So again, every test except for Unit 1 is a comprehensive test. But you have an extra 2 days to study for it too.
I have this after.
Yeah, I know. Okay, so let's talk about Unit 2 reactions. Okay, so what did we study in Unit 2? Okay, we had aldehydes, ketones, So we had aldehydes, ketones, acetals, ketals, hemiacetals, and hemiketals. So we're looking at these guys here. And these guys. Okay, so let's look at an aldehyde. And what if we oxidize an aldehyde? What do we end up getting? This is actually unit 1 as well. What happens when we oxidize an aldehyde? What do we get? What? Backbone's the same. There's only a primary backbone. We get the acid. So to get an aldehyde, we oxidize a primary alcohol. To get an acid, we oxidize aldehyde. Let's take this same 4-carbon unit and make it into a ketone. So we're going to take 2-butanone, oxidize it. What are we going to get? Nothing. Because ketones can't be oxidized. There's no H here. There's an H here, no H there. Requires an H on the carbon that's going to be oxidized. No H there, no oxidation. What if we took that 2-butanone, threw in an alcohol? Threw in ethanol. So we've got a primary and a secondary now. What do we make?
Make a new ball.
What?
Let me know.
A hemiketal. So what happens if we keep that environment? Bless you. Hemiketal, if we keep going, add another alcohol to the anomeric carbon. So this is going to be the full-blown ketone. So definitely be some acetyl ketone reactions, aldehyde ketone reactions. Unit 3 reactions. Definitely know how to make an ester the 3 different ways. What happens when an ester is in an acidic environment, in a basic environment. And then a multi-step problem. Okay, that's what we're looking at for a week from today. Okay, would you like me to go over some more reactions? I can do this all day. Pound later. Okay, presuming everyone wants me to go over more reactions, I can tell. Everyone answered me with a resounding, yes, more reactions. Okay, so let's do some acetyl reactions. That was a ketone reaction. Let's do some acetyl reactions. Let's take okay, what is that? First of all. Well, OCO, right? Okay, is H present? Yes. OH present? No. So that means that is an acetyl. Okay, so in an acidic environment, what'll happen is it'll come apart. Well, it comes apart from which it was made. So that means it was made from alcohols and an aldehyde. So let's look at the primary backbone. And then we have a couple of secondary backbones. Okay, so what's going to happen first, it's going to lose one of the alcohols. Become a hydroxyl group. Become a hemiacetal. And it's going to keep going and lose another one. So a full-blown acetal is gonna come apart in acidic environment. It's gonna come apart in terms of what made it to start with. Well, you made it from an aldehyde and an alcohol. So it's when it breaks up, it's gonna recreate the alcohol and aldehyde from which you started with. Name of that process is called hydrolysis. Hydrolysis in general is you take things apart and you end up with water left over. Okay, so is this over here? Should be. So that is not, yeah,
But what is that ketone? Isn't it an aldehyde?
which one?
Or the aldehyde? right?
It applied. Applied to the one above. I drew the blue line to distinguish between the two, and then I ended up drawing it in the wrong place. I'm gonna end it here, because the lab is kind of long. I'm gonna give you enough time to finish the lab in a reasonable amount of time. Now, we're getting some weather coming in, particularly next week. I'm talking about an atmospheric river hitting us next week. And we're gonna have kind of off and on weather till then. Like when I was coming here, the west, there was a pretty dark thunderstorm. So anyway, so for those of you who are, I know some of you travel, you travel like an hour. At least, right? At least an hour, right? And I know someone over here, like 2 hours, right? So, watch the weather. Huh? Well, if the weather, Thursday is the day, it's Wednesday night into Thursday was the atmospheric river. Problem is, it's gonna be fairly warm. I don't think you're gonna have snow. We'll probably have rain, a lot of rain. And the problem is, of course, trees fall across the roads, depending on how rural you are. It can really impact, yeah.
If your apartment parking lot gets flooded, you'll have to take on test.
I don't know, I think they fixed it pretty well.
Yeah.
Seems. Seems like the last time we had a couple downpours, it was kind of normal, it was about this much, which is what it used to be, not. That's funny. Okay, so I'll see you in lab. Hold off on doing calculations for Tuesday, people. Hold off doing those theoretical yield calculations. I'm gonna go over those next week. You have to do them just belated.
Today.
I don't, what doesn't fail, I'm gonna check my phone.
So you start off.
The second signature is cleanup, not when you finish it.
That's how I understood that you're supposed to have two signatures before you,
Link.
before I, upload it online.
Yeah, it's including the points for each one,
Yeah.
but you need this before you leave. I want to make sure everything's cleaned up. Then you clean it fine, that's fine.
Thank you.
Sure.
So I missed the last part of the soap making lab. And I was gonna submit the pre-lab, but I don't know if I need your signature before I submit it. Okay.
It's just- Okay, did you do the live?
I didn't do it, I wasn't there for it, I just got the data.
So,
Yeah, I get the one.
yeah, so,
Okay, and then,
did you do one for, the one for?
yeah, but I'll, I have a few more questions for you, I'm gonna let her get your questions, because my mic. If you want to ask me, if you want to ask me a question, go ahead, because I'm thinking.
I'm waiting for my ride. Is it okay if I brought my laptop and my, is it okay if I watch the Aspen on? Just watch.
Around the left? Oh, sure.
Okay, thank you.
Oh, you can always do that.
Okay.
So for the final, it's here in class. That last week, is it gonna be on the Tuesday or the Thursday?
It's just test five.
Okay,
It's not, I'm just saying the last, test is fine, because every test is final.
okay, so it's not cumulative. It's-
Well, every test is cumulative,
Yeah,
so.
kind of builds off the last one.
Exactly, that's
Okay.
why I can just kind of, fine.
Right, okay, so if I need to take it, if it's on Thursday, but I need to take it Tuesday, could I do that?
Yeah.
Okay, because I might have to, well, someone from, just going overseas, but, that and then. Oh, you were mentioning next week on Thursday, I did want to talk to you about that, I was the student last week who couldn't come because the tree fell down. Our property that I live on has no streets, but we're also prone to flooding on the main road, so. If I'm here for it, then I'm here. If not, then I'll email you that my property's all mushy, but Tuesday we should be fine. And then because we have a wet lab next Thursday, how would that work? I'm gonna
It's
tie that.
sort of a wetland and sort of not.
Okay.
What we're doing is we're taking the app.
Okay.
We're analyzing it, and it's not-
Mm.
and that. Do.
Okay.
And then you're doing a couple of things, it should take all,
Oh, okay.
it's a wetland, it's pretty short. The next week is not gonna be short. I mean, fairly lengthy one.
Okay, so if I don't make it to the wet lab next Thursday, but I get the data from my classmates and I write it out, could I still get full points for it, or would I get half points?
You should be fine doing this next week, but.
Okay. Say again?
You should be okay.
Okay, okay, thank you. That was really it. It was a lot.